Welcome back. This is Mrs. Colson, and today we are going over how to write linear equations from a graph. So the first thing we're going to talk about is slope-intercept form. That's what this is. Y equals mx plus b is slope-intercept form. So I'm going to go ahead and draw an arrow and label that. Slope-intercept form. And slope-intercept form is how we write linear equations. We write it in this form. Now the M stands for slope. That's what M stands for. The B represents our y-intercept. And the y-intercept is where our line crosses the y-axis. If we wanted to write it as an ordered pair, it's written as 0, b. So let's talk about linear equations. A linear equation is an equation whose solutions are ordered pairs that form a straight line. Remember, linear means straight. So it forms a straight line when graphed on a coordinate plane. When b is equal to 0, so when our y-intercept is 0, the relationship is proportional. So what this means right here is when b is 0, that means our line passes through the origin. And remember, the origin is 0, 0. So it passes through the center of our coordinate plane. When b does not equal 0, so when our y-intercept is not 0, so it's another number, it's -5, it's 4, it's 27, but when it's not 0, the relationship is non-proportional. That means it does not pass through the origin. And remember, the origin is 0, 0. So if we look at this graph right here, this is non-proportional. It does not pass through the origin 0, 0. When we look at this graph here, this is proportional. It passes through our origin. It passes through 0, 0. Linear equations can be written as y equals mx plus b. So this is one way to write a linear equation. How we do this, so today we're going to learn how to write an equation from a graph, from a line on a graph. So there's 3 steps we are going to follow. First, we need to identify what the y-intercept is. So we're identifying what b is. Remember, b stands for our y-intercept. That's where the line passes through the y-axis. If there is not a b, the y-intercept is 0. So what that means is if it's passing through the origin, it's passing through the center of our graph, b is 0. Then we need to find the slope, find our m. Remember, m stands for slope. So we're going to find the slope between 2 points. Remember, if it's positive, we calculate the rise over the run. Remember, positive, we're going up the mountain. If it's negative, we calculate the sink over the swim. That's for a negative slope. And then after we find m and we find b, we are going to substitute them in or plug them into slope-intercept form. So whatever your slope is, you're going to plug in for m. Whatever your y-intercept is, you're going to plug in for b. So let's go ahead and get started with some examples. So for our first example here, we're going to follow these steps. So I'm just going to look right back up here. It says identify the y-intercept, where the line passes through the y-axis. So looking at my graph here, I'm first going to label my x and y-axis so I know where to look. This is my y-axis, so I'm going to look, where is the line going through the y-axis at? Well, it's going through right here. That's at 4. So my y-intercept is 4. If we wanted to write that as an ordered pair, it would be 0, 4. Okay, so we did our first step. We found our y-intercept. Now we need to find the slope. In order to find the slope, we need 2 points to calculate that. So I need to find another point here on my graph. I want to find a nice integer so that it's easy for me to calculate that. And I know that this is a point right here. It's passing through all 4 corners. So that's a nice whole number for me to work with. Remember, anywhere on this line is a point, but we can't tell exactly where this is. This is somewhere between 0 and 1 on our x-axis, so I can't tell exactly what that number is. That's why we want to find one where it's going through all 4 corners. Because this is nice, a nice whole number for me to work with. So now that I have my 2 points, I see that my line is going down. This is a negative slope, so I'm going to need to calculate the sink over the swim. So I need to go down and right to get to my next point. So I'm going to go ahead and calculate that. I have to go down 1, 2, 3 units. So I went down 3. That's a -3. When you go down, it's negative. Then I'm going to the right 2 units. When you go right, it's positive. So I'm going over 1, 2. So I went to the right 2 units. Remember, sink over swim. So I went down 3, over, and then I went over 2. So my slope is -3 over 2. Remember, it's always the change in y, so your vertical change, over the change in x, your horizontal change. Now that I have my y-intercept and my slope, I am going to substitute those values into my equation, y equals mx plus b. So I'm going to just write y equals mx plus b, and then I'm going to substitute those values in. Y equals, my m is -3 over 2, -3 over 2. Don't forget to bring down your x, plus my b is 4. This is how we write an equation in slope-intercept form. So now we could use this equation to find more points on our graph. I could plug in any value for x and solve, and it will tell me the output, the y value. And that would give me another ordered pair on our graph. All right, sliding on over. Example number 2. Again, we need to write an equation in slope-intercept form for this line. So remember, slope-intercept form is y equals mx plus b. Following our steps, step number 1, identify the y-intercept. That's where the line passes through the y-axis. So I'm going to label my x and y-axis. I look at my y-axis. My line is going through right here. Oh, that's at the origin. It's at 0, 0. So my b is 0. And then I need to find the slope. Again, this is a negative slope. My line is going down. So I need to find another point. And I see another point right here. You may have seen this point up here. We can use any of these 2 points to calculate the slope. So just pick any 2. I'm going to pick these 2 right here. And I'm going to calculate the sink over the swim. So how many units down and how many units right? I'm going 1, 2, 3, 4, 5 units down. When you go down, that's negative. So -5. And then I'm going to the right 3. That's a +3 when you go to the right. So the slope for this is -5 over 3. Now we have everything we need to write the equation for this line. Plug in m for m and b for b, and we have our equation. Y equals -5 over 3x plus our b is 0. So this is one way of writing it, but you won't really see it written like this. Whenever the y-intercept is 0, we don't write it like this. We leave this off. So we could also write this as y equals -5 over 3x. That's another way of writing it. Now let's go over number 3. Again, we're writing it in slope-intercept form. So that is y equals mx plus b. We want to write an equation for this line here. I'm going to label my x and y axis. And I'm going to find my b, which is my y-intercept. That's my first step. So I look, where is it crossing through the y-axis at? It's going through right here at 2. Now I need to calculate my slope. So I need to find another point to do this. We need 2 points to find the slope. So if I look, I can see that another point on this line is right there. It's crossing through all 4 corners, so that's a nice integer for me to be able to calculate the slope. If I look at my line, it's going up. So remember slope, dude, puff, puff, positive. It's going up, so this is a positive slope. I'm going to calculate the rise over the run. So how many units up and how many units right to get to my next point. So I'm going up 1, 2, 3 units, and I'm going to the right 1 unit. So positive 3 over 1. 3 over 1. This can also be written as 3. 3 over 1 is the same thing as 3. Now I have everything I need to plug those values into slope-intercept form to write the equation for this line. So y equals 3x plus my y-intercept is 2. So this is the equation for this line right here. Again, what that means is we could take any number, plug it in for x, solve, and we will find y. That would give us an ordered pair. So if I wanted to, I could pick any number. I could plug in the number 1 in for x. I could solve 3 times 1 is 3 plus 2. 3 plus 2 is 5. So y equals 5. I plugged in 1 for x. In my output, what I got when I plugged that in, what I got out of it was 5. So that's my y. So that just gave me another point on my line. I could go over to 1 on my x-axis and up to 5, and there's another point on my line. All right, number 4. Y equals mx plus b. Let's identify our y-intercept, where the graph is crossing the y-axis at. It's crossing right here at 3. And then we need to calculate the slope. This is a positive slope. Our line is going up the mountain, puff, puff, positive. So I need to find another point to calculate the slope of this line. So I see another point right here. And it's going right through all 4 corners, nice and perfectly right through those corners. So that's a good another point to use. I'm going to calculate the rise and the run to my next point. How many units up and how many units to the right. We are going 1, 2, 3, 4, 5 units up. So that's a positive 5. And then 1, 2, 3 units over. That's a positive 3. So the slope of this line is 5 over 3. Now I'm going to plug those values into slope-intercept form to write the equation for this line. Y equals 5 over 3x plus 3. Really important not to forget the x. When you're substituting the value for slope back into the equation, you do not want to forget x, or else it'll look like 5 over 3 plus 3. which is not the case. All right, so a couple quick reminders. This is slope-intercept form. Y equals mx plus b. Our m represents our slope. Our b represents our y-intercept. And the y-intercept is where it crosses through the y-axis. Thanks for watching. Bye.